Humbert here. Today we're going to be going over Unit 5, Notes 5. So we're going to be talking about quadratic applications. So this is Unit 5, Notes 5. So when you're looking at this, we want to figure out when do we find the vertex of equation. So here are some words we want to look for. If it anywhere in the problem talks about the maximum or the minimum. So if it talks about the maximum or the minimum of the vertex of the equation, that's when we need to use the vertex. So what is the vertex of the equation? Well, that's where we use x is equal to opposite of b over 2a. Once we get that, we plug it back in to get our y. Now, typically, our y is going to represent our maximum or minimum of the equation, and x is going to be what we use to get there. So that's when you're going to use the vertex. So when do you need to solve the equation? So you're going to need to solve the equation when it asks you when is it going to hit the ground, or basically set equal to 0, or if it asks for a certain height. So it's going to be reaching a certain height. Okay, and to solve it, we typically use the quadratic formula. Now remember that the quadratic formula is also the same as using the zero product property. The quadratic formula will always work on the word problems, but unfortunately sometimes the zero product property will not. So just keep in mind that if the zero product property does not work, you do need to try that quadratic formula. So let's go ahead and let's take a look at number 1. So it says that the height h of an object t seconds after it is propelled upward with an initial velocity of v is represented by h is equal to negative 1/2 gt squared plus vt plus h, where g is the gravitational pull and h is the initial height. So let's go ahead and let's plug that in. So suppose an astronaut on the moon throws a baseball for upwards of 2 meters. So that's going to be our height. The ground with an initial velocity of 10 meters per second, that's going to be our v. And the moon is, and suppose the gravitational upon the moon is a constant of 1.6. We're going to plug that in for g. So I'm just going to go ahead and write this out. So we're going to have negative 1/2 times 1.6 t squared. Now I'm not plugging anything in for t, times 10v, or plus 10v, plus 2. And this is going to be set equal to 0, so we're going to try and figure out when it returns to the ground. So instantly I know that I'm going to have to be using that quadratic formula. So when I multiply those two together, I end up getting negative 8.8 t squared plus 10t plus 2 is equal to 0. So now I'm ready to use the quadratic formula. My a is negative 8, my b is 10, and my c is 2. So I get opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So remember that first thing you want to do is type what's underneath the radical into your calculator. So that's going to be 10 squared minus 4 times negative 0.8 times 2. Okay, so when you do that underneath the radical, and maybe you should try calculating it out with me just to see if you're on the right track. You should get 106.4. Now all of that's going to be divided by 2 times negative 0.8, which is going to be negative 1.6. So now we need to go ahead and split this into 2 different versions. So first thing I'm going to do is my plus version. So I'm going to get that x is equal to negative 10 plus the square root of 106.4. So I'm going to type that in my calculator, hit enter, and then divide that by 2. And when I do that, I get negative 0.75. Well, negative time doesn't make sense, so I'm going to hope that the next one works out better for me. So I'm going to do negative 10 minus the square root of 106.4. Again, hit enter, calculating that out, and then I get negative 1.6. And now when I do that, I get 13.25. So that makes much more sense. So it takes 13.25 seconds for it to return to the ground on the moon. So let's go ahead and let's compare that with the Earth. So it's going to be the same height and the same velocity, but now my gravity constant is 9.8. So let's go ahead and re-plug it into that formula. So I have negative 1/2 times the gravity constant, and then I have t squared plus my velocity of 10, and then t, and then my height of 2. So what I'm going to do next is I'm going to go ahead and multiply those out. So negative 1/2 times 9.8 is going to give me negative 4.9 t squared plus 10t plus 2. So my a is negative 4.9, my b is 10, and my c is 2. So let's go ahead and plug that into the quadratic formula. So I have opposite of b plus or minus the square root of b squared minus 4 times a, this should be a negative, times c, all of that over 2 times my a. Okay, so now I need to simplify underneath the radical first. So I'm going to do that 10 squared minus 4 times negative 4.9 times 2. And when I do that, I get 139.2. Again, I want you guys to be calculating that out with me. And that's going to be divided by a negative 9.8 when we multiply that out. So let's do our two versions. So we're going to have negative 10 plus the square root of 139.2. We're going to enter that in the calculator, and then we're going to divide it by a negative 9.8 after we have the top simplified. And when you do that, you get negative 0.12. Again, negative time doesn't make sense, so I'm going to go ahead and throw that one out. So now let's try our minus version. So negative 10 minus the square root of 139.2. Hit enter and divide that by a negative 9.8. And once you do that, you get 2.42, which makes a lot more sense, and we're going to write seconds. So on Earth, it only takes 2.42 seconds to return back to the ground. On the moon, it takes 13.25. So we're just going to write, when we compare them, it takes longer on the moon. Why do you think that is? Well, it has less gravity. So if you think to science, since there's less gravity, there's not as much force pulling it down, bringing it back down to Earth. So let's go ahead and let's read through number 2. It says Jimmy John's is tracking its sales of sub. The manager uses the quadratic representing this is negative 25x squared plus 250x plus 400, where x is the number of subs sold and y is the total revenue. What is the maximum revenue served and how many subs were sold in this revenue? So when we're talking about maximum revenue, that's going to be a vertex problem. We're talking about the maximum. So it's going to be x is equal to opposite of b over 2 times a, because again, since it referenced maximum, we know that we're calculating out the vertex. So here I'm going to get negative 250 divided by negative 50. And when I divide those out, I get 5. So 5 is the number of subs that they need to sell to reach their maximum revenue. So now we're going to try and figure out what that maximum revenue is going to be. So what I'm going to do is I'm going to take my original quadratic, and wherever I see that x, I'm going to put in a 5. So I get negative 25, and I'm going to put 5 in instead. Take all of that out. And then I can go ahead and just type this in my calculator. So 25 times 5 squared plus 250 times 5 plus 400. And when I do that, I get 1,025. So that's going to represent my maximum revenue. And I know that from what they assign the variables to be up there. So my maximum revenue then is $1,025. Let's go ahead and let's take a look at number 3. It says a projectile is shot vertically up in the air from the ground. Its distance y in feet after t seconds is given by this quadratic. We want to find the values of t when y is 96 feet. So they're giving us a set value that we need to figure out when it's going to reach. So that's one of those certain height problems that we talked about earlier. So that's where we're going to have to actually solve it. So let's set it up to solve it. So we're going to have our height equal to 96. So now we have this quadratic. Now you guys have been working with quadratics long enough that you know that the quadratic has to be set equal to 0 in order to solve it. So I'm going to start by subtracting 96 from both sides. So then I get 0 is equal to, now what I'm going to do to help myself solve this is I'm going to write it in standard form. So I'm going to take that guy first because I like my square term to come first, and then this guy. And then lastly, that minus 96 is going to become my c value. So now I'm ready to plug this into the quadratic formula. So I get that t is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so the first thing I want to do is simplify out underneath this radical. So I'm going to figure out what 96 squared minus 4 times negative 16 times negative 96 is. So when I do that, I end up getting 3,072. That's going to sit underneath the radical. Now that's going to be divided by 2 times negative 16, which is a negative 32. So now I'm going to do my two versions. So I'm going to have negative 96 plus the square root of 3072. So I'm going to type that all into my calculator and have it finished out. Then I'm going to hit enter and divide it by 32. And when I do that, I get 1.27, and that's going to be labeled seconds, okay? Because that's our time measurement. So now I'm going to do my minus version. So now I'm going to do in my calculator negative 96 minus the square root of 3072, hit enter, and then divide it by 32. And once I do that, I get 4.73 seconds. Now this one is going to have two answers, and this is why. If you think about a projectile being launched, here's the pattern that it follows. It goes up, then gravity takes over and it comes back down. Well, if 96 feet, excuse me, is right here, it's going to cross it twice, which is why we have two different seconds. Okay? So let's take a look at number 4. It says a pan is to be formed by cutting 2 by 2 centimeter squares from each corner, and the sheet metal is folding into sides. If the volume of the pan is to be 444 square centimeters, what should the dimensions of the original piece be? Okay, so first thing we want to do is calculate out the volume, and volume is length times width times height. So you have a height of 2 here. This length is x minus 4, and this length is x minus 4. And here's how you get the minus 4. You're taking 2 off from each side, so that's going to become x minus 4. So what we have here is 2 times x minus 4 times x minus 4, and that's going to be equal to the volume of 441. So I'm going to start by distributing in that 2. So I get 2x minus 8, and that's going to be multiplied by x minus 4. So notice that I'm only distributing that into one of the two parentheses. So now I need to simplify this, and I'm going to do that by using the box method. So I'm going to have 2x minus 8, and then I'm going to have x minus 4 going this way. And now I'm going to multiply into the box. So 2x times x is 2x squared. Remember, when you multiply x to the first times x to the first, you get x squared. Negative 8 times x is negative 8x. Negative 4 times 2 is negative 8x. And negative 4 times negative 8 is a positive 32. Okay, so we get 2x squared minus 16x plus 32 is going to give us 441. So now I want to set this equal to 0 because I'm actually going to be solving this. So I'm going to actually subtract 441 from both sides. So I get 2x squared minus 16x. 32 minus 441 is going to give me negative 409, and that's going to be equal to 0. And so I'm not very confident about plugging this into the quadratic formula. So I'm going to, or into the zero product property. So I'm going to use the quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. So the first thing I want to do is simplify this underneath the radical. So in my calculator, I'm going to do 16 squared minus 4 times 2 times negative 409. And when I do that, I end up getting 3,528. So that's what's going to go underneath my radical. Now all of that is being divided by 4. So now I'm ready to, sorry, by 4? Yes, by 4. Goodness, losing my marbles. So now what we're going to do is do our pluses and minuses. So we have 16 plus the square root of 3,528. So I'm going to start by calculating that out. And once I do that, I'm going to take it and divide it by 4. And doing that, I get 75 point, oops, then I have to divide that by 4. Goodness, I forgot that. And I get 18.8. So that's for one of them. Now let's check our minus version. I have 16 minus the square root of 3,528. So again, you want to simplify that out in your calculator before you move on and divide. So you take that answer, divide it by 4, and you get negative 10.8. Well, negative distance doesn't make sense, so we're going to go ahead and throw that one out. And we're just going to deal with this 18.8. So the question originally asked, what are the original dimensions of the box? Well, we know what x is, so this distance right here is going to be, or this whole distance, sorry, is going to be 18.8. However, what it's asking for is that dimension. So we're going to have 18.8 by 18.8. So that's what this box would have been before you cut that out. And we're going to label that centimeters. So that's your final answer for number 4. Now, let's take a look at number 5. It says, one of the banks of the Chicago River there is a water cannon called the water arc that sprays recirculated water across the river. The path of the water arc is given by the quadratic model. Okay, here's the quadratic. X is the distance across the river. Y is the height of the arc in feet. What is the maximum, okay, I need to use vertex, height of the water sprayed from the water arc? How far across from the river? So the maximum height is going to be represented by y based on what they told me. The distance across the river is going to be represented by x. So this right here is a vertex problem. So we're going to have x is equal to opposite of b over 2 times a. So let's go ahead and let's actually multiply out that bottom. When you do 2 times negative 0.006, you end up getting negative 0.012. So now I'm going to take negative 1.2 and divide it by negative 0.012. And when I do that, I end up getting 100 feet. So I'm going to take that 100 feet and I'm going to plug it in for every single x up there. So 0.006, and now instead of writing x, I'm going to put 100 and then square it, plus 1.2, then I'm going to do 100, plus 10. So now I can go ahead and type this in my calculator, 0.006 times 100 squared, plus 1.2 times 100, plus 10, and I end up getting 70 feet. So this is my max height, and this is the feet across. Okay, so that's the answer to number 5, and that concludes your note video for today. Thank you for listening.